This is the AP Statistics Chapter 10 review. How quickly do synthetic fabrics such as polyester decay in landfills? A researcher buried polyester strips in the soil for different lengths of time, then dug up the strips and measured the force required to break them. Breaking strength is easy to be measured and is a good indicator of decay. Lower strength means the fabric has decayed. For one part of the study, the researcher buried 10 strips of polyester fabric in a well-drained soil in the summer. The strips were randomly assigned to two groups. 5 of them were buried for 2 weeks, and the other 5 were buried for 16 weeks. Here are the breaking strength in pounds. Do the data give good evidence that polyester decays more in 16 weeks than in 2 weeks? Can instruct and interpret a 95% confidence interval for the difference in the two mean breaking strengths. To do this, we are going to do a 4-step problem. Remember, you need to do a state, a plan, do, and then conclude. On the state, you need to tell us what you're trying to solve. So we want to estimate mu sub 1 minus mu sub 2 at a 95% confidence level. We're going to let our null hypothesis in this case be that mu sub 1 minus mu sub 2 equals 0 versus our alternative hypothesis of mu sub 1 minus mu sub 2 is greater than 0, where mu sub 1 is the true mean breaking strength at 2 weeks and mu sub 2 is the true mean breaking strength at 16 weeks. Next, we're going to come up with our plan. On your plan, you need to say what method you're going to use, and then you need to check your 3 conditions. So if the conditions are met, we will carry out a 2-sample t interval for mu sub 1 minus mu sub 2. There are 10 strips of polyester that are randomly assigned to the 2 treatment groups, so the random condition has been met. Because each of these groups only has 5 items in them, if they were both 30 or more, we could just automatically say that it's in normal distribution. But since it's less than 30, we are going to have to graph the data. And if you examine the dot plot, neither group displays strong skewness or any outliers, so we can use our procedures as we need to on this problem. To check for independent, because this is an experiment, there is random assignment, and these 2 groups of pieces of cloth can be viewed as independent. Also, knowing one piece of cloth's breaking strength gives no information about the breaking strength of another piece of cloth. Next is the do, where you're going to actually do the calculations. So from the table, you would need to input that data into your calculator, and you would need to calculate the mean and the standard deviation for population 1, and the mean and standard deviation for population 2. Next, you need to find your degrees of freedom. Remember, degrees of freedom is your sample size minus 1. So for population 1, the degrees of freedom would be 5. And for population 2, it'd be 5 minus 1, so the degrees of freedom would be 4. And the degrees of freedom for population 2 would be 5 minus 1, which would also be 4. You're going to pick whichever one is smaller, but since they're both the same, our degrees of freedom will just be 4. Now you would go to your table, or your T tables, and you would look at degrees of freedom of 4, and we are looking for a 95% confidence interval. So you'd go over on degrees of freedom of 4 until you get to the 95th confidence level, and that's going to give you a T-star value of 2.776. Next, we're going to use the following equation to find our interval. So you're going to do your x1 minus your x2, and that's going to give you 7.4. And we're going to do plus or minus our T-star value, or our critical value, times the standard deviation of the sampling distribution, which in this case will give us 20.8. So once we get our values, we're going to do the subtraction first, and then we'll do addition to get our 2 different values to get our interval. So we are 95% confident that the interval from negative 13.4 to 28.2 captures the difference in the actual mean breaking strength for polyester, like the samples that were buried for 2 weeks, and polyester like samples that were buried for 16 weeks. Does your interval in the previous example suggest that polyester decays more in 16 weeks than in 2 weeks, and justify your answer? So let's come back and let's look at our interval. Our interval says it's going to be from negative 13.4 to 28.2. Now, if there was no difference, then that would have a value of 0. Since 0 does fall in this interval, it is a plausible value. So this does not show that there is a definite difference in strength when polyester has been buried for 2 weeks instead of 16 weeks. High levels of cholesterol in blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol level reduce heart attacks? The Helsinki Heart Study recruited middle-aged men with high cholesterol but no history of any other serious medical problems to investigate this question. The volunteer subjects were assigned at random to one of 2 treatments. 2,051 men took a drug to reduce their cholesterol level, and there was a control group of 2,030 men that took a placebo. During the next 5 years, 56 men in the drug group and 84 men in the placebo group had heart attacks. Is the apparent benefit of the drug statistically significant? Perform an appropriate test to find out. Again, this is going to be a 4-step problem. We're going to start with our state. This tells us we're just going to do a significance test because we're just testing the significance. So we do need to give our null hypothesis, our alternative hypothesis. You need to make sure you define your parameter, and you need to give your alpha or significance level. So we hope to show that the drug reduces heart attacks. So we have a one-sided alternative. Our null hypothesis is going to be that P1 minus P2 equals 0, and the alternative hypothesis, or H sub A, is P1 minus P2 is less than 0, where P1 is the actual heart attack rate for middle-aged men like those who are taking the drug, and P2 is the actual heart attack rate for middle-aged men like those in the study who are taking a placebo. Since no significance level was given, we're going to let our alpha level equal 0.01 to help reduce our type 1 error. Next, we need to make our plan. This is where we state what method we're going to use, and we check our conditions. So if the conditions are met, we will do a 2-sample z-test for P1 minus P2. The data comes from 2 2 groups in a randomized experiment, so the random component has been met. Because this is a proportion, we're looking at the p-values, not the mu. We do need to check the number of successes and the number of failures. For both groups, the number of successes is, in this case, how many people had heart attacks, and failures would be people who did not have heart attacks. And since all of these numbers are at least 10, the normal condition has been met. To check for independence, this was randomly assigned and it was an experiment, so they are independent groups, but we also need to check to make sure each individual in the group is independent of everyone else. And knowing whether one man has a heart attack does not determine whether the second man has a heart attack, so the individuals in the group are also independent. Next is the do. So we first need to find our p-hat values for both groups. So we're going to find our p-hat 1 and our p-hat 2. Next, you need to find your pooled data. So to find your pooled data, we are going to add the number of men in both groups who had heart attacks over the total number of men in both groups. And so our pooled data is going to be 0.0343. Now to find our test statistic, we're going to do this z. So we're going to do our p-hat 1 minus p-hat 2 minus our hypothesis, which is 0, over the standard deviation for our sampling distribution using this pooled data. So since the probability of success for the pooled data is 0.0343, that's going to be our probability of success times the probability of failure over the sample size for population A, and then probability of success and failure for the pooled data over the sample size for sample 2. And this will give us a z-value of negative 2.47. Now remember, the z-value, you can go to the z-table, and it will tell you the area to the left of that on the graph, which in this case will tell us our p-value. So if you go to our z-table or table A, you're going to get a value of negative 2.47. That's your z-value. We look for the area that corresponds to that, and the area that corresponds will be 0.0068. So this means our p-value in this case is going to be 0.0068. So for our conclusion, we're going to compare this to our alpha level. So since our p-value of 0.0068 is less than our alpha of 0.01, the results are statistically significant at the alpha equals 0.01 level. We can reject the null hypothesis and conclude that there is convincing evidence of a lower heart attack rate for middle-aged men like those who took this drug versus those who only took a placebo. Let's describe a type 1 and a type 2 error in the setting of the previous example and give possible consequences of both. So a type 1 error occurs if we reject the null hypothesis when it's actually true. In this case, it would be concluding that the drug lowers heart attack rates when it actually does not. This could result in prescribing medication to patients when it is ineffective and some patients could die. A type 2 error occurs when you fail to reject the null hypothesis and it's when it's actually false. That should say false, not true. In this case, this would be concluding that there's no lower heart rate attack when taking the drug when there actually is a lower rate. This could cause doctors to not prescribe this medication